my talk about Slick in the field. I decided to give that talk because a couple of months ago I did a project in Slick, and well, when you start with Slick, you discover a lot of things that maybe you were not expecting. Some things you realize immediately when you read the documentation for the first time. Other things you realize later on. And part of the problems is how to model your code in Slick and how to kind of change your mindset and do different than ORM frameworks do. So a little bit about myself. My name is Renato Guerra Cavalcante. That's how you pronounce it in my language, which is Portuguese. You're right, it's totally different, but we pronounce it like that. And so I'm founder of the Belgian Scala user group, and together with another guy in Belgium, we started association of independent contractors, strong typed IO, where he's blogging, I'm not yet, and I'd like to blog more about that. I tried many things in my life. I have a degree in psychology, and psychology is quite nice. It's about abstract thinking applied to people, and I decided not to do that, to apply things on people. And then I tried philosophy. I came to Europe to study philosophy, which is abstract thinking applying to nothing. And then I realized that as a developer, I could have abstract thinking applied to computers and not to people. Of course, that computers impact people later on, but that is a problem from customer service, and that's far from me. So it was a nice job. So this talk is not about building complex queries in Slick, because I can do that. So I will not talk about that. It's not about solving the left outer join problems that you may have with Slick, and not about reducing verbosity and noise. So it's more about how organize your code, how to forget ORM, how to think different about persistency. And so that's the agenda. What is the memory persistency challenge that ORM frameworks try to solve? How you code without associations, and that's one of the main things that you have to do if you do Slick. And then I will show a thin layer that I built on top of Slick to help me solving some of the problems that I found. And I will show more or less how I organize my code. And a little bit about testing. I do believe, guys, that you know how to test, and I will not spend much time on that, so we'll see. So I think there is a nice blog from Martin Fowler where it's called ORM Hate, and where he's saying everybody's blaming ORM and Hibernate GPA because it's not good, it sucks, blah, blah, blah. But he will say there are other things there that they are solving, and that it's not only solving the problem of taking your model that's an object-oriented model and put it on tables. There are other things they are solving, and we forgot about that when we just say, okay, I not use ORM, but we forgot that those frameworks are solving that as well. And the main problem is that you have two representations of the data, one in memory that's very easy to manipulate, and one in your tables. And you have to keep them in sync, and that's just hard. So what ORM frameworks offer to you is that they help you to manage the object lifecycle. You have a new object, you persist it, you got an ID, it gets an ID, and then you can modify it, it gets dirty, and then you know that you have to save it back. And those frameworks help you manage these things. It offers you optimistic lock via versioning. And so this is built in Hibernate and GPA and other frameworks. Ordering for associations. If you imagine, I will show an example of just a very small model where you have an album and tracks are a sequence of tracks from in the album. And if you persist it to get back, you need to have the ordering of the tracks. Track 1 has to stay the track 1. You don't want it being put on the end of your list. So Hibernate solved that. And one-to-many and many-to-many relationships. One-to-one, it's an easy one, and I think it's easy to do in Slick. But one-to-many and many-to-many, you don't do it. You do differently. And so you have to learn how you should not try to do that, because it's not work in Slick. And you have to, when you choose Slick, you have to know, okay, I will do different. I will find another way to express my relation. I'm not saying that you don't have relations. You have relations. The relations are in your database. There is foreign key from one table to the other, so the relations are there, but you don't express them in an object-oriented style by having association from one object has a list to another. And caching. GPA Hibernate offers you cache. And basically, the last two you cannot solve with Slick, and that's, well, basically caching is, if you have immutable data structures, it would be very hard to have a cache for that, because you have something in the cache, you modify it here, the cache still has the old version, so you have to do it by hand. And I don't think it's something that you should try, because it will add lots of complexity in your code just because you have to maintain that cache. So it's not a good thing to do. The other things you can solve in Slick, but as I said, you need a thin layer on top of it, and I will talk more about that later, in a while actually. So that's how we would model in object-oriented style. I don't have an association from artist to album here. I want to keep it simple, and also an album can only have one artist, but also to keep it simple. But you see what I want to show. An album has an artist, and it has a sequence of tracks, and this track should be, I should preserve the ordering of this track, in the sequence of tracks. But that's how you have to do in Slick. And you have the ID of the artist, and in the track you have the ID of the album. Pretty much like your relational model. That's how your table will look like. But if you want to represent those relations, so if you have artist ID and album ID, and in your code you want to represent those relations. You want to see that you have a relation from album to an artist and to tracks, but here you have the IDs, and that's like a weak and poor way of expressing that relation. So you can do things like that. Basically here you are just creating a shortcut to a query. So you model, you say, okay, I have a case class and I don't have an artist, I have an artist ID, but then I can fetch it when I need. So you're doing some lazy loading, you put just a shortcut to a query. It's not bad, but I don't think it's ideal. You'll see later why. And basically you are faking that relation by putting a query behind it. And it's very common, and you see in the mailing list people are doing that, and I think it's a not bad solution. Only that you fetch, every time that you want the artist, you fetch it again. But you have to see if you need cache in that or somewhere or not. Or you can do that, and which become very dangerous, and well, when you're doing Scala, you probably don't want to do that. And I saw that a couple of times, and later I realized that it's much more dangerous than you can imagine, because if you have an album, well, that we know how dangerous that, but if you have an album and you clone that one, what do you have in your cloned object? What will be the value of artists and tracks in the cloned object? It will be reset to null and an empty list buffer. So it's probably not what you're expecting, so it's really not good. And the thing about Slick, and if you see how we configure things, is that the case class or your tuples, they are isomorphic to your tables. They are just your rows. So if you do Slick, embrace your rows. Embrace the fact that you're coding against your rows. And well, in Scala we say that functions are first-class citizens. In reactive programming, our failures are first-class citizens. So let's say that if you do Slick, rows are first-class citizens, and that's what you get in your code. So which design pattern promotes the idea of having a row as a first-class citizen? Well, that's active record. So basically the idea for active record is you bring your row into a row representation in-memory representation of your record, and you work on that. And it gives you some methods to work on that row, like save, delete, update, and so on. Active Record got lots of negative criticism because it mixes your domain model with database infrastructure. And that's the case of the previous one, where the artist had your case class, the album, has a relation, a dependency on the Slick table to fetch the artist when you need it. So that's more or less the kind of criticism it got. So, but to create active records, you need some helpers that provides you CRUD operations. Otherwise, you have to code it over and over again. And because CRUD operations, they are very tight related to the object life cycle. And if you have an active record, if you want to work with rows as first-class citizen, and you need to manage the life cycle of this row. And then you need some helpers, you need those CRUD operations. And moreover, is that IDs are crucial for entities. Value object, it's okay because value semantics, you can just drop them and create them again. But when you have entities, you have IDs, and you have to manage that. So Slick will not give you that out of the box, and you have to build some stuff around it. I'll show more or less what it is. So look, I have here a full object, very simple name and ID, a table, and whenever I want to save, I have here the table query, and whenever I want to save this full object, I have to do that, returning fulls map ID, insert full, and I got the ID here, and then I can copy my case class. You know, you guys are doing that? No, that's the way to do it. I think everybody's doing that. Well, that's too much for me. If I have to do that everywhere, I get bored very, very fast. And what happens is, what we need here is we need a way to connect the ID from my case class to the ID column. If I can connect those two, I have enough to build CRUD operations around this class. So as such that I can have a method that says, okay, save this full ID and give me back a full that has an ID already internal set for it. So I don't have to repeat that many, many, many times. So what kind of things we have that does that for us is, well, basically are generic DAOs. That's what they are useful. And they give those sorry, I have my thing I have to put here this. So if you have a generic DAO, you have enough information to build those things. And but to do that, you need to have a known column in your table that will contain the foreign key. You need to have some methods to extract the ID from your model. So you need something that say, okay, in that model, that's the ID that I have. And in the other side, and say, okay, that's the column that represents my ID, and you have to connect those two. And you also need some facilities to add the ID back to your model. So, okay, that's easy. Let's create a generic DAO for Slick. And it should not be hard. And then there is a quote from Christoph Vogt. I think I pronounced correctly your name. And, well, when implement an abstract DAO, be prepared to face a lot of challenge and get to the edge of your Scala type system skills. And learn quite a bit about type inference, order, implicit parameters, etc. And the etc. here is quite scary because you don't know what is behind it. You discover that on the run. And the problem is that I saw that when I had already implemented one. So otherwise I would not even try. So I will show some code. And one more thing, when I did that, I was using Slick 1. And so I did a project where I put this, where I created this Slick DAO. And we use that in production. And Then we moved to Slick 2, and though I refactored that to Slick 2, and I think 1 week before this talk, I realized that I want to change it. Because in Slick 2, the table queries is a kind of DAO. So it was not a good match. And then I said, okay, instead of having DAO where I pass a table query, the promoted way of doing that is to create extensions for your table query. So I refactored it, and I said, okay, it's not a DAO anymore, but there are some extensions that will take that principles that were in the DAO, but now are query extensions for my table query. And so let's say I give up from this DAO thing, but I continue to think about this way of connecting my IDs, the column and the ID in the model. Okay. So let's see here what we have. Wow. I move it to here, I think. Okay, much better. So the first thing that I want to show is, let's see if I can easily put that here. Okay. Where's my mouse? So, it's can you guys read it? It's okay, it's very big. Huh? So the first thing that I did was, later I will explain why I'm using the cake pattern here. It's important. So I have a trait that says, okay, you have a table with ID, and here I'm saying, I'm showing what just an ID, a column with for I, which will be my ID. And then I have an identifiable table that is just an extension of a table, a Slick table, this one, and with a table ID. And then same constructors. And one important thing, I need here the base column type of I. And that's why I have here the cake pattern, because I need a profile, but I don't know from where it comes from, where I get that profile, so it will be mixed in later. And I need it to have access to a base column type. So that's the first building block. Then the next thing is it's there. That's what I was looking for. The query extensions, and here I have. Where is the mouse? Okay. So the query extension. Again, I'm now importing the tables, and the tables is the file where I have the table with ID. Okay. So now I'm importing here, and I say, okay, there is a base table extension that does the list, paged list for me. And there is the save and delete, but I don't know how I can do that yet. I can only know how I do save and delete if I have an ID. So this base table extension does not have the notion of ID. It's only the identifiable table that has an ID here. And it has to be, it extends in using implicit class actually. It's not extension in object-oriented meaning. I need to pass here a table query that is an identifiable table from model and ID. And I have two methods that I have to implement, extract ID and with ID. And then the other methods I can implement myself. I don't have to implement them over and over again. You can see here, add is doing the returning insert and return me the ID here. And when I do save, if I implement the extract method, extract ID method, I can say, okay, if I have an ID, I will add it. If I don't have an ID, I will add my model to the database. I get the ID from the add method, and I will fill my model using the ID. With ID, I get a model and the ID. So it's pretty much that. And if I have an ID, I will just update. Okay, so now I could connect the ID of my model by implementing the extract ID, and with ID, I can connect now the ID that are in my model with this column. And there are many projects on the internet doing that. There are the guys from Virtus Lab. I don't know if they are here, but they have a project called Unicorn. It's very similar. There is another one, Slick integration. I don't know the state of this one, but it's also very similar to that. And I was yesterday talking with some guys from Boulder Radius that and they have done also something very similar. So it's a problem that people are trying to solve, and yeah, it would be nice if we can merge our efforts and work together. So let's see how you do here. By the way, I'm using the same model, more or less. I reduced my model by the supplier and coffee that you know from the Slick examples. So here I have a supplier. I only have a name and an option ID. And I have a schema where I have everything. Okay, I lied. It's not coffee, it's beer. I did that because, you know, the guys from Slick, they are Germans, and they are pretending drinking coffee, but we know they are drinking beer, so I adapted a little bit. And because we are here in Germany, I thought it was a good thing. So let's say we have a suppliers table, and this is implementing this identifiable table where I say, for this one is an int. And in this file, I only put the table and the suppliers table query. And it's very important I use uppercase for my table query, because very often I get conflict with methods called suppliers. And it's not really the convention in the Java world, but for me, in Scala it's more or less accepted. So this is my suppliers, my schema. And so later I have another class that is the suppliers extension that basically shows you that you can see here, the extension, it's an implicit class, so it will add those methods to the query using the identifiable table extension. And I only have to implement those two methods here, okay? I say, okay, that's how I extract my ID, and if you have an ID, that's how I will copy it into my model. And I'm done. And from this identifiable table, I have some very nice methods like find by ID, delete by ID, find option by ID, and I don't have to code that over and over again. And by the way, I can here I can choose, if I put, for instance, another type here, you see that it's not compiling anymore. It should not. I know why. It's here. Okay. I will show it later when we move to another piece of the code. So basically, the ID of my option, the type of my ID has to be compatible with the type of my table. Yeah, probably it's because they are along and int, they are interchangeable somehow with in the driver. I'm not sure. Anyway, but that's still too much for me to write that. Like, where is it? Where it was? Query extension. I can also get rid of that. So I move it to here so I can easily code. I can also say, okay, I don't want to implement that over and over again. I have another one that is already there for me, and it's the entity table extension. And the entity table extension, I don't have to say which integer I have, because it will be in my entity. And the only thing here is that the difference is that the entity table extension will has to be it's a table for some entity. And if I have that, I can just implement the extract and the with ID by default, except that my entity has this with ID method. So actually what I have to do is I have only to implement the with ID method. So let's do that. So this guy now has to implement the extends entity ID for supplier, and IntelliJ fills that wrongly. We have to do that by hand. By the way, what we are doing here, now I only have to implement the with ID. If my class implements the entity, and if my table extension is of, if my table extension implements the entity table extent, then I'm done. And of course, that the with ID in the suppliers, I didn't try it yet, but it's something that we could do with a macro. So you don't have to repeat that over and over again. So we have the building blocks, and we can have, one more thing. If you see here, supplier extensions, I have two extensions here. One for my table. Did I remove this one? It's strange. It's not. It's not synchronizing. I have another version here on my other screen that does have. Okay. I will try to change that here. Know what I do? I will put it in mirror so I can easily code on my screen as well. Okay. Okay, now I have the same screen to be much easier. Okay. It's strange because I had that code here on my computer, on that screen, and I changed it, and it should synchronize. It's the same IDE, so. Okay. So there's example one. Okay, I go back now to the query extension, and so this first one is adding some method to my table query suppliers, and this other one, and here happens the let's say the active record one is an extension for the supplier itself, and it adds the method save that will forward to supplier save, the delete. I have one here that forwards the add. If I want to save and get the ID back, I can add this one, and I have another method here that it will also add a method to a supplier, to an instance of supplier. And so there are two kind of extensions, one for the table query and one for your object. And what you can see, the usage, and that's what I was looking for in my project, was, okay, if I cannot do object associations, I want to, in code, be able to clearly express that. So I'm basically saying, okay, I have a supplier, I will print it as not persisted, I save it. This is the method that's being added by the extension here. I can have some count, and this is added in on the table query, and I can delete. So now I don't need to have database logic on my code, and I can express that via methods. Okay, so and probably to not compile now. So let's see. Okay, I will run example one and just print everything that I want. So it's a way to put all the slick queries behind and have something that is very close to what we want, the problems you want to solve in your business logic. But this is the simple one. I will show you now the example two, where it's a little bit, we have a little bit more I have here. I will create 2 suppliers with beers. And basically, when I create a supplier with beer, I save the supplier, I run from 1 to 5, and I create a beer with a price. And there is a factor here because I want them to have different prices. So full, the factor is 1, bar, the supplier bar, the factor is 1.23, and then I will show what I have. And here's, let's say, the business logic part. I have a supplier, and I have the most expensive beer. And this is a method that's being added to the supplier. So it's like the first example that I show where you put some shortcuts to your queries, but here's different, it's being added via class extension. And the nice thing about that, and that's the difference in my opinion about the criticism about against active record is that you mix things, but here you're not mixing, you are enriching your supplier class with extensions. So, and you get the feeling that you have navigation from one entity to the other by extension. So in this case, the class is totally pure. You can send it to an actor. You can do what you want. There is no state that you're sure that you can serialize it. You can easily, you'll not have issues related with the fact that you have Slick behind it. So that was a good way for me to solve this kind of problems. And and then if you look there inside, this extension is just calling a query extension on the suppliers. And the query extension, that method is being here used and composing with another query in the beer extension that I will show you in a while. And what I do, and I think it's a nice way to organize the code, is I always start my query. Here, I'm returning the query. I'm not materializing the object. I always try to call it a query, just to have, when the code completion give me the queries, the methods that I want to use. I protect them to my components because I don't want to use that outside my components, because I want them inside Slick, inside the components, shielded here. And normally on these supplier extensions, the extensions for the model, I don't want to depend here on the driver. I want only the JDBC session, the database session. So if I have a query, the query has to come here, and then I use it from here. And that's all, because, well, as you see, I open the beer extension, and here I have 2 queries that I need to build this one. I need 2 actually. I need first to select the max price per supplier, and then I select the beer object that has the max price. And here's just another method. And here's another example I have on the beer. I think I don't have it on my example. I can show you. Well, here is an extension on the beer model that gives me the supplier. Once I have the beer, I can go and fetch the supplier. And here I'm fetching the optional, which will be very strange to not have a supplier for a beer, but that's... So by doing that, I believe that I could code as if you had relations, because you have to express that in your code, but you can't with Slick. And I don't want to put Slick behind my case class. So with the extensions, I get close to it. So I will go back to my code in a while. So I also want to show how I organize it, how I use the cake pattern to build that all. One thing, when you see the Slick examples, yeah, you start with a driver somewhere that you define, and then you create your tables, and then you do some queries, and then, well, it works. It's very nice. But that's not how you work with your code. You separate things, and there are many ways of doing that. If you are doing Hibernate, it's more or less there for you. You model, you put annotations, and you say to Spring how it has to initialize that, and everything comes for you. So you don't think about how you organize it here. But in Slick, you have to do yourself. So you have to find a way that is good for you to organize your code in some meaningful ways for you. And one thing that I do, I don't mix. I try to, my kids' classes are here, my tables are there, my query extensions are in another place. And because, as I will show, I have like a schema object where I put all my tables and nothing more, and the table queries, but nothing more than that. I avoid using tuples as model, because there is a lack of semantics in tuples. So I don't want to see _1, _2. That's just awful. So I use tuples only to create link tables, of course, because there it would be silly to create another model object just to represent a link. And well, when you do joins, you get tuples, and of course that's how the way it works. If you're doing join of two tables, that's okay. You get a tuple. First thing to do is to explode that tuple to variables. Don't use _1, _2. Or if you have lots of things coming from your join, then try to, in your extensions or in your DAO, if you prefer to code like that, try to create a local model where you can put the data from your tuple that has some semantics. One of the things that we have done, we had some queries that did some calculations of totals over different tables, and I got then 4 total results, statistics results. And then I create a total statistic class that was only to encapsulate the 4 values that I was getting instead of passing a tuple. It's just to add some more semantics. And okay, back to code. So I will close everything and start one by one again. First thing, the tables. Yeah, now it's okay. I know. Who here? Okay. So first thing, I have this schema file where I put my tables. Again, I need to mix in with the tables because here is where I get my table with ID. Okay, so the tables that I have to extend. And I need the profile. The profile is just a small class, a small tray that gives me the JDBC driver. And so I have here my schema. And I have the query extensions that says, here I need tables and profile. And if you take a suppliers, and that's the tricky part. I even don't know if, I have this trait, active slick, and that I took inspiration from the guys from Unicorn, from Virtus Lab. They have done more or less like that, and it's a good idea. So the active slick, I will tell you what is active slick later. Well, it's the name of the project, actually. It has the tables, the query extensions, and the profile. So all the things that the active slick is providing. And there is this model extensions. And why I have that, and let's see what we have here. The model extensions is a trait that implements schema and all my extensions. So supplier extension is here and is here as well. And what is amazing is that if you do like that, you don't have cyclic reference between your traits. So here you require model extension as in a self-type annotation, and here it's not a self-type annotation, but model extends supplier extensions. And why I need that? Because when I'm on my extension, I must be able to. Is there a missing method here? I think I deleted too much, no? Okay, we'll see it later. So I need to have, yeah, there is something strange with my, you see I have 2 versions of the suppliers extensions in the same IDE. The nice thing is I never had that, only when you do a demo that it appears. I have 2 versions of the same file on the, okay, let's see if it will compile it later. And So I need here to have access to the beer. And eventually on the beer extension, I need access to the supplier extension as well. And a nice way to do that is to have this model extension. Then you solve the puzzle. Because if you start to do your composition, say, okay, this one, in the self-type annotation, say, okay, this one needs this supplier extension, and the other one, you do that as well, you get a cyclic reference, and you not compile. And then at the end, I have a components where I put everything. And of course, in production, you not do that. You not put the hard code. The whole thing here is to avoid to have the hard-coded driver, but for the demo purpose, it was easier to do like that. Okay. So a little bit about testing. And when you do Hibernate, I think it's very common it's very easy to bring your data into memory. And there are a lot of computations that you do in memory because it's just easy. And but with query composition in Slick, you realize that it's much easier to let the computation happens in the database. So we do some queries, you do some aggregations, and then say, okay, why not? Why are you bring so much data into memory if I can let the SQL engine to compute that for me and just give me the results that I'm interested in? And but the consequence of that is that part of your business logic of computations that are supporting your business logic is being executed outside of your the JVM on the SQL engine. So basically, you have from the beginning have a strategy to write integration tests for that. Because otherwise you have very easy to see that part of your code is not being tested because it's on the database, it's being executed in the database, and it gets hard for you to solve problems. And my experience on the first project where I used Slick, my experience with in-memory DB H2 for instance was quite painful. And the reason is that we were doing lots of joins, left joins and all kinds that you can imagine, and very huge. We had very big joins, and what happens is every time you have an alias in Slick for every query that you build. And in our case, it was so big that it was very slow for testing, because we realized that H2 database was creating this alias class constantly, and it was constantly garbage collecting on that, and it was not performance enough for testing. We were not happy with that, and then we said, okay, we are not going to use in-memory database. And by the way, it's actually not a really good idea. The best is to use your real database, because you're testing the SQL engine that you use in production, so it's much better to use your own database. But of course, then you have a real integration test. You need to have some infrastructure. But nowadays with Docker, things get much easier to get in place, and so it's not a big issue. And the thing also, when you do integration tests, you know you need data. You need valid data to put it in the database. And but that's some general tips. I think every one of you here knows how to do these things, but you have to do that from the beginning. I always do kind of small DSLs to generate data for me, data that are valid to put on the database. And from the beginning, start to do that. Random strings, random numbers, just fill your object with random data. And if you need some specific data, then make your DSL search and say, okay, give me a random album with some tracks, but make sure that I don't have more than 10 tracks, for instance. And then you describe the data that you have, much more like you have in Scala check or things like that. And what we have done, it's ways to say, okay, I want that, but I just want it in memory. I just want it in memory so I can do some unit test, and then with some extra, like a processor that you can pass and say, okay, this processor will put on the database. And then you have data in the database on your MySQL, Postgres, or Oracle, and you execute your test. The tests that are testing your query execute against those data. So, but you have to do that from the beginning. Don't wait to do that later, because you realize that's a lot of work. And we still have 10 minutes. So I put a URL. So before it was called Slick DAO. So because I changed that approach of doing query extensions, I decided to call it Active Slick instead. Because, well, the reason for me to do DAO is because I want to promote the idea of the active record. So it was not a real DAO, it was the active record. So I said, okay, it should be Active Slick. And since it's not reactive, so it's clear for everybody that's not reactive, but Active Slick. And here's my Twitter handle and email address. You can contact me. And we have some time for questions. Yeah? Mm-hmm. Mm-hmm.
Have you looked into using either structural types or if performance is an issue, maybe an implicit macro?
Yeah.
Throw that away? Automate that boilerplate?
Yeah. I think that with a structural type, you not have performance gain. In the other, this the other. Yeah. Boilerplate. Yeah. Well, I would like to do that with macro, because I think it's the better way. I have tried shapeless, and they have these lenses that you can with symbols define, but actually it will not work because you have to. The idea has to be on the. It cannot be. You cannot create a lens for the entity because the entity is not a case class. It's a trait. And so if the idea of situation was to have a lens based on the entity type, and then it will work for any case class. But you cannot do that because the shapeless entity lenses will not generate that for you. So you have to do in your case class. But if you have to do in your case class, it's the same of adding the with ID. So my idea is to make a macro for that, and then exactly have a type class that is generated by a macro, and then it will just define this operation for you. And then you have everything. You just have the table, just have to implement a table with ID and entity and put the macro somewhere.
The second thing is not actually a question. We have Stefan Zeiger here.
Yeah.
And we hosted him last year, and I can attest that he does not drink beer.
Okay. So next time I will put suppliers that supplies beer and coffee. You drink beer, Christopher? Okay, look, I will adapt. Thanks. More questions? Yeah? So I think if you with Scala 2.11 you solve this problem is solved because you don't have the limitation on the case class. But in any case, I think if you have 50 columns in your table, you have a legacy system, so probably you don't. It's very hard to modify it. But there is another problem there, and so if I understand, you want to have a table, a tuple that maps to your table that has 50 columns. Yeah, but you can have different table definitions that pick parts of your table. That's not a problem.
You can also have different projections that comprise subsets of your bigger entity class. That might be a useful.
You mean when you have one-to-one relations and you can say, okay, here those 3 columns become another object inside? Okay, is that what you mean?
Yeah, you could have different case classes, but map through different projections from the same table, select table embedding.
Yes. You can have a table that has the 50 columns and different projections for, yeah, it's also an option, yeah. More questions? Yeah. Yeah. No, I have no recommendation. And the thing is that I think it would be very hard to implement such a thing. If you have immutable data structures, you get something, I put in the cache, you do another query. Yeah, okay. The only thing that I can say is that what is in the cache is equals what is in the table. But as soon as you modify your case class, well, you have a new instance now because you did a clone of this case class. So your cache is not up to date anymore, and you have to update it yourself. Having this notion of knowing your ID, you could eventually say, okay, update my cache, and I know how to find it because I know where is the ID. But you have to ask that automatically. I don't think that would be easy to do that, and you probably get more issues than benefits from that. So what I would say is just cache on where you just make sure that the objects you keep them in memory where you're using them. I have tried many things on that project, and I have tried to create like sort of aggregates that were classes, no case class, and I took the case class, I fill my object with case class, and so it was like a facade, a mutable facade around this case class, so it was working as a cache. For our use case, it was okay, but I don't think it can be used everywhere, and so you kind of have to find your ways to do that. Yep. Yeah. Yeah. Well, what happened was that we had lots of joins. So every time that you have a query, you get some aliases, and the driver for H2DB has some garbage collection issues. If you create lots of aliases, I don't know what was happening. I didn't investigate further, but it was constantly garbage collecting, and then say, okay, that was the issue. Yep. Mm-hmm. Yeah, no, it was not more sophisticated. Well, the fixes that I had were very generic. Just for each object, I had ways to generate just strings and numbers, integers or longs that I could put there. I was not using in Scala check that say, okay, give me so many objects like that and build it for me. But I was just say, okay, I need an album, I need tracks, and I need an artist. And I have now this model, and I could say persist it or persist it, don't or leave it in memory, just that. But yeah, you could do something similar. I think I was discussing yesterday with some guys here, and my current project I'm not using Scala check, but I realized it would be very very good for the project because it's much more like what we're saying, like generate lots of things for me. I don't care what it is. I just need data. And more question? Don't know if you still have time. I think we still have 1 minute. Come on, one more question. Okay, guys, so we can finish here. Thank you very much. Hope you enjoy it.